Okay, so we're starting chapter 6. It's getting a little tougher. So hopefully you're having a chance to read and go through the questions in the book, because I think that'll be really, really helpful. Just hearing it once in class with me going through the slides probably is not enough to get it. So you definitely need to make sure that you're going through the material in the book and you're answering the checkpoint questions. You're also getting credit for that. So hopefully that's working for everybody. So we're going to talk about something called functions today. And this is a way of splitting up your program. So we call this modular programming. And the reason for this is to make your program, more manageable. It's easier to look at. So if you're looking at everything in the main function, it's hard to really task different people with different tasks. It's hard to correct code if it's incorrect. It's hard to reuse anything you put in main because you have to copy and paste it. It doesn't transfer into other programs. And so if we're able to split down into these modules, that we call them functions in C++, then it allows us to have the flexibility of bringing these things that we feel that are useful into other programs that we have more easily, having to share with other people, having to task things off to other people so that somebody can take one particular thing that they're working on, somebody else could take something else, and those could be different functions that they're working on. They can pull it all together. And so it's much more manageable when you do this. And so I know it seems easier to write everything in the main function, just because then we don't have to worry about all of the syntax of writing functions. But it's nice to think of things as functions, like what is the purpose of this particular piece of code versus this one? Can we break it into modules? And if we break it into modules, those modules will be useful because they can be reused in other programs or in the same program. It's easier to change them. It's less likely to make mistakes because if you ever notice, it's easy to copy and paste things. But when you're copy and pasting, if you decide to make a change to that code, you have to go through and change everywhere you copied and pasted it, and you might forget to change one particular part, and then that part is left unchanged. So it's very manual to go through and fix things like that, and it's easy to make mistakes. And so if you split things into function, you can just say to keep using that function, and if you have to make a change, you make a change to that one little piece, that one little function, and then it changes everywhere you used it. So you don't have to manually go through and fix everywhere you used it. So I think that's very helpful, but it's hard to kind of get used to the syntax of how to do that. So we're going to talk about that today. Okay, so whenever someone says a function call, that means that you are actually telling that code that you have, that little piece of code that you have to execute, you're just implementing it, you're doing it basically. So when you're setting up that piece of code, that's called a function definition. And there's some things that you have to know when you're doing a function definition that we're going to talk about in just a second. You have to tell C++ about the different parts of the function. So we're going to talk about that. That's called the function definition. But whenever you want to use the function, that's called a function call. Okay, using that code is called a call. So if anyone ever says calling a function, that means you're just using the code that's in a function. Just a fancy way of saying that, but a lot of people say that. Okay, so we are going to have to think about some things when we're doing our function definition, when we're setting up our functions. So we have to think about first the return type. So when we're writing a function, there's functions that don't return. Those are called void. So if you think about void, think about like what that word means. That means does not return, okay? And then if you do return, you have to say what data type you're returning. So are you returning a string, which would be text? Are you returning an integer, which would be a whole number? Are you returning a decimal, which would be a double? Are you returning a Boolean, which would be true and false? What are you returning? What does your function do? So if it's going to figure out if a number is divisible, then it probably returns true or false, because that would tell you that would be a Boolean. It's going to tell you if it's divisible or not divisible. If it's going to do a calculation and return a decimal number, then it would return a double. Okay, so you have to figure out what's it returning. Maybe it's not returning. Maybe it's doing a calculation that's printing the answer and it doesn't return at all. So return means that whenever you tell it to use the function, whenever you call the function, if it's going to send you back data, that's called returning. Okay, so if it sends you back data, it's returning. Okay, then you have to come up with a name for your function. So a name, you follow the same naming rules that you use for variables, except normally when you're naming a function, you'll come up with an action name. So if you're calculating Fahrenheit to Celsius, name it, calculate Fahrenheit to Celsius. Okay. Or if you're converting, maybe you want to call it converting Fahrenheit to Celsius. But usually use an action word like converting, calculating, because you're doing something. It doesn't have to, but normally your function names will start with a lowercase letter, and you can't put spaces in your name. So if you want to call it calculating Celsius, then you don't put a space between calculating and Celsius. You can put an underscore, but you can't put a space. You can't start your name of your function with a number. You can write out how to spell the number, but you can't start with a number. Okay, so it follows the same rules as you have for variables. A parameter list, this would be in parentheses, any information that your function needs to execute. So if you want to convert Celsius to Fahrenheit, okay, then you need to pass in a Celsius value. So what do you need in order to do that calculation? That would be your parameter that you need. What do you need? That's the information you need in order to do it. So we'll take a look at some different examples of that. And then anything you actually want to do, like your calculation, if you're printing it out, what are you doing in your function? That's in the body, that's in the curly braces. So we're going to take a look at some examples so you can see what that looks like. Okay, so if you look, we actually have been using a function called main. So the name of the function is main. The return type is int. We haven't been returning anything other than 0, and we'll just be returning 0 this whole class. If it returns something other than 0, that means there's a problem. So it returns 0 at the end. And actually, if you take that off, it actually defaults return 0 for you. But it's good to put that on there. There's no parameters for main, so it's empty. But even if you don't have parameters, you still have to put the parentheses there. And if you needed anything to do the main function, you would put those in parentheses, but we don't need anything, so we leave it empty. And then the body of main is from this curly brace, this is the opening curly brace, to this ending curly brace. That's called the body. Is everybody with me so far? So far, so good, not too bad. Okay. So we talked about this. The main returns an integer, and we always just return 0. But some functions will be void, which means they don't return. So if you have a function that's void, that means it doesn't return. So for this particular function is called print heading. And see how if you have 2 words in your function name, you just push them together, just like your variable names. And normally you'll capitalize the first letter of the second word so you can tell the difference between the 2 words. And normally you want to start with a lowercase letter for your first word. You don't need any parameters in order to print this heading that we have. You could have a parameter of what you want to print. So this could be something coming in instead of always printing monthly sales. You could have a value coming in here of what you actually want to print instead. But this one, every time you use this method, is going to print monthly sales and then have a blank line. So you can use it as many times as you want. If you tell it to execute print heading, it's going to print monthly sales. And you know, you can keep doing that in a loop if you want to just print. I know it's a very simple method. Oh, not method, I'm sorry, function. It's a simple function, and it's going to print monthly sales, but it doesn't return anything. It's not calculating anything, returning anything. If I accidentally say method instead of function, that's because I use way more Java than C++, and sometimes I get in Java mode, and in Java we call it a method, and in C++ we call it a function, but the same idea, they're both the same thing. So I apologize for that. I'm trying really hard to say function instead of method. Okay, so calling a function, in order to call it, you just say the name of it. So if you looked back at this one again, the name of it was print heading. So here, whenever you want to use it, you just say print heading and you put parentheses. And if you had anything in there for parameter, you would put an actual value in there that goes to that parameter whenever you want to call it. But this one doesn't have anything, so it's just empty parentheses and then a semicolon. And this will tell it to go there, do that, and print that monthly sales. Okay. So you still have to put the parentheses though. You can't take those off. So it's just name of the function, parentheses, and then you're done. Okay. Everybody okay with that so far before we start adding parameters and everything? Do you have any questions? Okay, so let's take a look at the full program. So you can see here that you actually have this new function up here. See, it's separate from your actual main function. See, main, this is the body of main, from this curly brace to this curly brace. This is a different function up here called display message. And this one says hello from the function display message, okay? So whenever you tell it to go there, it's gonna go up here. And so down here, it always does main first because main is what it knows to do whenever you run the program. So it goes to main, and when it says hello from main, and then it gets to this display message on line 22. It says, oh, let me look for a function named display message. And it says, oh, it's right here, okay. So I'll do whatever's in there, okay? And so it's going to print hello from the function display message. So you can see that in the output down here, hello from main, hello from the function display message. Whenever it's done executing this function, whenever it's done executing this function, it comes back to wherever it called it from. So this line 22 tells it to go up here and do that. But whenever it's done, it comes back to line 22 and it moves on to the next line. So then it says back in the function main again. Okay, and then it's done. So it goes to the function, does whatever's in there, and then it comes back and it finishes the rest of the code. Okay, does everybody see that? You see how they're separate? You can't put one function inside the other. You can't put the curly braces for one inside the curly braces for the other. So they're completely separate. Okay. Do you see how this display message is actually first and then the main? There's a reason for that. If you actually move this display message after, it won't work. It needs to have these new functions that you have before they're used. It needs to know about them before you use them. So they need to be first, okay? Or we have another way of writing it if you want to write them second. But if you aren't going to write any prototypes at the top, which we'll talk about in just a bit, then you need to put the new functions that you have before you have main, before they're used. Just like you declare your variables before you use them, you declare your functions before you use them. So you put that one up here and then you use it down here. Okay. Does anybody have any questions so far? Are y'all okay on Zoom? Everybody's quiet today. Okay. All right. So you can see we talked about this. So first it goes to main and it does hello from main. Display message tells it to go up here and do whatever code is in here. That's where you get this C out. And then it comes back and it does this C out. So it always finishes whatever is inside this function you have. And then it comes back to where it was called from. Does everybody understand that flow? Okay. All right, so main can call any number of functions. So you can have as many functions as you want in your program and they can be called from main, but they don't have to be called from main. So let's say you have a function A and a function B. Well, you can tell main to go to A and function A can tell the program to go to B, right? So you can go into a function and then that function can tell you to go to another function. And then that function can go to another function. You can keep going. But when it's done with everything it has to do, when it goes in order and it goes to different functions, it comes back to where it was called from originally. Okay. So even if like you go from main to A and A goes to B, when it's done with B, if there's anything left in A, it'll come back and do that. But if there's nothing left in A, it'll go back to where it was called from in main. Okay. So you can keep telling it to go from here to there to there. Now, if you don't ever call anything from main, then it'll never happen. So you can create as many functions as you want, but if you don't ever tell it to execute them, you never call them, then it doesn't have a way to get to them. So C++ will let you have them there for future use, but if you don't ever call them, then they never happen. If that makes sense, like creating them for later, but if you don't ever tell it to use them, then they'll never happen. Makes sense, okay? So you want to think about a few things when you're doing your header. What's the name of your function going to be? What is the purpose of your function? Your functions only have one function. And what do I mean by that? They only have one thing that they're working on. So like if you're trying to convert Celsius to Fahrenheit, then that would be the function that's what that function is working on. Just that one thing. It's just returning that one thing. If you want to go from Celsius to Fahrenheit in one and then Fahrenheit to Celsius in another, that would be two separate functions because one is calculating Celsius and one is calculating Fahrenheit. Okay, so each function needs to have its own thing that it's working on, and it can only return one thing. It can't return multiple things. Like you can't have a calculation for this and a calculation for this and return two different answers, one for this calculation, one for this. So if you're trying to calculate two different things, then you need to have two different functions, okay, to do that. The parameters tell you what information is needed to do the function. So if you're doing a calculation, what values do you need to do that calculation? Sometimes you won't need any values, so sometimes you might need 1 or 2 or 3. Those are your parameters, okay? And then what are the data types for the parameters? So do you need integers, doubles? What do you need for your function? So again, we'll take a look at many examples to see what this means, okay? Oops. All right, so I was talking about this before, the prototype. So as long as you put your functions before main, before you use them, then you're okay. You don't need to do the function prototype. But if you put your function after main, then you need to tell the program about your methods that you're going to have by putting a prototype at the top, okay? So what's a prototype? A prototype looks like this. So it has what return type you have. So for this print heading, it's void. What's the name of it? And then in parentheses, what parameter or data types do you have? And this one doesn't have any parameters, so it's just empty, okay? So basically you would put this print heading at the top of your program, telling C++ that you're going to have a function called print heading, and then later you would tell it more details about it. You would give it the body of the actual function. So this isn't the actual function, it's just the prototype telling C++, I'm going to have this later, okay? So it looks like this. So here you have all of your, includes, your preprocessors, and then down here you have your prototypes, okay? Now, you see that you don't have your first and second functions declared up here before main. So we need to have these prototypes that see when you're doing main and you're going to use this first and second function. If you didn't have these prototypes, C++ would be upset. It would say, oh, you didn't tell me about these functions. What's going on? If you give it a prototype, it says, oh, okay, I understand. You're going to have this, and this will be later in the program. So then you can see that you do have them declared, you just have them later. Now, if you put them first, you don't have to do that. But if you put them second, just in case, if they get moved around, then you put the prototypes to tell C++, I'm going to have this function called first. It doesn't have any parameters. And then it's going to print out, I'm inside the function first. Okay. And then second is going to print out, I'm inside the function second. Okay. So here, when you do it, what's going to happen first? It's going to go inside main first, and it's going to print, I'm starting in a function main, right? Then this tells it to call this function first, okay? And it's okay with that you don't have the first function up here because you have the prototype saying that you have it. So then it looks around for that in your program and it finds it here. And it says, oh, I am inside the function first, okay? Once it prints that, there's nothing else in this method, this function to do. So it comes back here to where it was called from. It says, okay, we're done with that. And then it goes to the next thing. And this says, go to a function called second. Okay, look for one called second. Okay, print this. I am now inside the function second, right? Okay, I'm done with that. So come back. So come back here. And now I can print back in the function main again. Does everybody see the flow of how that works? See how we get from one function to another function? So we go from the main function to the first function, second function, and then it comes back to where it was called from. Okay. Any questions? It's on 2 different slides. I apologize for that. It didn't fit nicely on one slide. Okay, so when you're doing your prototypes, just make sure that at the top of your program, it has to know about them before you get to the main method. The main function, it's just really in my head. The main function. You must either put them first or put the prototype at the top. Otherwise, you'll get a compiler error. You want to put them in order, and you want to make sure you put any parameters you have. That one that we had didn't have any parameters, so it's just empty parentheses. So if you want to send data to a function, we've been talking about these parameters. This is an example of using a function that has parameters. So this POW stands for power of, okay? So POW is going to take the power of one number, and it's going to use the second number to know what to take it to the power of. So it needs 2 numbers to do that, okay? So we're going to say that A and B are numbers, right? They're variables that hold numbers, okay? So when they set up this function, when we didn't set it up, they actually have a function called POW. Then it's going to take in 2 numbers. Now, instead of using numbers, you can use variables that hold numbers, that's fine. But you can pass in the two variables by putting a comma between them, okay? Now, what it'll do is it'll actually return the answer of the power of this one to this one, and it'll save it in C, okay? So it's just a basic example. Whenever you're using the function, whenever you're calling it, and you pass in values for the parameters, that's called arguments. I like to tell students, you know, arguments are when you're using the function, think of them as answers, like argument answer, okay? Arguments answer the question of what values we're using for the parameters, okay? Think of the parameter as the questions. If you ever heard someone say, these are a list of the parameters for something, okay, that's the rules. Those are the questions that you have. That's the information that's needed. And then the arguments are the answers to those parameters. Okay, so think arguments are when you're using the function, and parameters when you're setting up the function. That's the requirements for the function. Does that make sense to everybody? Do you understand the difference? It's kind of hard to get used to in a way. And if you use them interchangeably, people still know what you mean. It's just you want to try to get them which one's which straight. Okay. All right. So here's an example of a function that has a parameter. So this one is void. It's not going to return. It's called display value. That's the name. And then there's a parameter here. Anytime you have a parameter that you're setting up for your function, when you set it up, this is setting it up, not calling it, you have to see what data type that parameter is. What's that variable going to be? Now, a parameter is just a variable that you're using for that function, okay? So you have to come up with a data type for it. So you're going to take in a number for this particular function, okay? And then you're going to print the value is whatever that number is, right? So if you pass in 5 to this function, it's going to print the value as 5, okay? So all this is doing is setting up a variable for a value that comes in, and that value goes into this variable and then it gets used. But when you're setting up the variable to hold the value that's coming in, you need to tell C++ if that's an integer, which is a whole number, a decimal, which would be a double. Is it a string, which is going to be text? Is it a true or false, which is going to be a Boolean? What information are you taking in when you're using this? When you get a value, what data type is that value going to be? And you are going to tell C++ about that here when you actually are doing the function header. You're going to say the data type for each of the variables. Now, if you have more than one variable, you're going to put a comma and you're going to say the data type for the second one and the name of that variable as well. Okay. So this one doesn't return anything, it just prints, but we can return. We'll see some examples of returning. But does anybody have questions so far? Everybody okay? Are you completely lost, or is this too easy? Okay. All right. So here is that actual example with the code. So because mean is first and the function is second, the newly created function is second, there's a function prototype here. So this function prototype says that we are going to have a function named display value. It's going to be void, meaning it doesn't return anything. Okay. It doesn't send any value back, which we will see some that return, so you can see the difference. And then it's going to have an integer that it takes in. Okay. Now you don't have to see the variable name here whenever you do the prototype, but when you actually write the declaration for the function, you're going to put the name for the variable and the body of the function. Okay. So if I go to the second slide, you can see here that this is the actual function header. Here it says it's void. The name of its display value. And then here is the actual name for the variable. So it is taking an integer and the name of it is num. Okay. What's it going to do? It's going to print off the value as whatever value it came in for num. Okay. So here, when we're in main, the first thing that happens is it says I am passing 5 to display value. Okay. Then it's going to call this function called display value. This is an argument, meaning answer to the parameter that was set up in the function, right? So this is called the argument. It can be a variable or it can actually just be a number, right? But over here, it says that that value has to be an integer. So if I tried to put a decimal number in here or a string or a Boolean, the program would have problems because it would try to put that value into that variable and it would say that doesn't work because that's the wrong data type for that particular value. So the value you put here has to match whatever data type you have here. So here you're putting 5. So just remember the data in parentheses goes to the variables in parentheses. And if you have more than one, they go in order. So if you have 2, the first one goes to the first, the second one goes to the second, and so on. Okay, so that value 5 goes into num, and it's going to print the value is 5, right? So that's this right here. Then it's done with everything in this function, so it goes back here, and it's done with this line 11. It's already executed that method, that function. I'm going to get it out of my head. You know what's going to happen in my next class in Java? I'm going to start saying function. I'm going to get the mix match. I wish they would just call them the same thing. Java and C++ are very similar, except for that's one of the main things that I get tripped up on is that Java calls them methods and C++ calls them functions, but they are the same thing. And I just switch my terminology when I'm teaching both classes. I'm just so used to saying method. I just can't get it in my head. So I just try like, don't say method, say function. I'm trying. More than half the time I say function, sorry. Okay. Then it's going to print now I'm back in main. I guess you'll be used to the word method whenever you get to Java. Okay. So does that make sense to everybody? That program? All okay so far? All right. So we talked about this. I know it was on 2 different slides, but that value of 5 is called the argument, and it goes into the num variable, and that's what gets printed here. So just remember, value in parentheses goes to variable in parentheses. This is called the parameter. These are the requirements to do this function. What do you need to do this function? This is the information you need to do it. This is a value you need that's going to get sent there. That's the argument. That's the answer that fills in this variable. The answer is the question. If you try to call this function display value and you don't put a value in here, let's say you just have empty parentheses, it won't compile because it'll say you need to have a value that goes into num. If you don't have one, you can't do it. So if there's a parameter, if there's one parameter and you try to call the function without a parameter, it won't let you. If it says that there's 2 parameters and you try to call it with 1 parameter, it won't work, right? So you have to have the same number of arguments as parameters. So if it says there's 2 parameters, you have to have 2 arguments. If there's 1, you have to have 1. If there aren't any, then you can't have any. So whatever's in parentheses here, it has to match here, whatever values, number of values you're having. Okay. All right, so we already talked about this. If you have parameters, then your prototype needs to have the data type of the parameters, but doesn't have the variable name. The header will actually have the name of the variable, but the prototype doesn't have the name of the variable. It just is telling C++, this is what we're working with, but you don't need to know the details yet. You'll see that later when you see the header. Okay, so this is what the prototype looks like. This is what the header looks like when you're actually creating the function. And then you also have a body that goes with that tells it what to do. And then this is the call to that particular function. So if you were doing an even or odd function, these are the 3 different, this is how you set it up, saying I'm going to have it. This is how you declare it with all the details. And this is how you call it when you're actually using it. Does that make sense, everybody? When you are calling your function, you never put a data type with your argument. The reason is because you're not declaring something when you're using it. You're filling in the answers for what you're using with that particular function. So setting up the function header is where you're setting up the data types for everything. What you need, you're setting up the requirements, right? When you're using it, when you're calling it, you're not setting up the requirements, you're filling in the answers to the questions. So you're just answering the question. So it should be a variable that has a value or just a value. If you want to just put 5 in there, fine. If you want to put a variable that holds the number 5, fine. If you want to put an equation that comes up with the answer to a calculation that gets sent there, that's fine too. As long as C++ gets a value, it doesn't care how it got the value, from a variable, from an equation, or just the value itself. It's like, as long as you get me the data type I need, we're good. If you need an integer and you give me a calculation that comes up with an integer, that's fine, right? As long as I get an integer. Okay. Okay. So whenever you're calling a function, it's going to copy the value to put it into the parameter. Okay. So if whatever you're working with is not the same data type, it will get promoted or demoted to match the parameter. Okay. So if it's a double, then it'll just get demoted to an int. If it's an integer, okay, but try to keep the same data type because you have to realize that's happening and you're not going to get the full value that you have, okay? So whenever you're doing it, again, you want to I mean, you will have problems if you try to do something like it wants a Boolean and you're passing in an integer, because those data types don't work together. So, you know, int and double you can get away with. If you pass in an int and it requires a double, then it'll just actually add the decimal on there. Like it'll make it a double. So that's easy to do. But if you're trying to go from number data type to like string or to, then that's not going to work. Okay. And then if you have more than one parameter, the first argument goes to the first parameter, the second to the second, and so on. Okay, so this is a program with multiple parameters. You have the prototype at the top. Remember, there's no variable names up here. That's just the prototype. Main is first. That's why we need the prototype. The show sum function is actually on the next slide. So let's take a look at that, then we'll come back. So this is the show sum function. It's not going to return, so we want the word void here. You will see some that return, so we will talk about that. The void is a little easier when you're first starting off. So we look at all the void ones first. So void means we're not returning. Show sum is the name of the function. It has 3 parameters, which means it needs 3 numbers. So number 1, number 2, number 3, they're all integers. Okay. So what's it going to do? It's going to add them together and print it. Okay. Now it could have added them and actually returned the answer, but in this case, it's adding them and actually just printing it. Okay. So let's go back here. So in main, what's going to happen is you're going to ask the user for 3 integers. Okay. And we talked about this before. If you want to, you can take in all 3 values on the same line when they actually just, as long as they put them in the right order, although you're adding them, so it doesn't really matter what order they put them in. It would matter if it was an equation where you were dividing or something like that, but you're adding, so it doesn't matter what order you put your numbers in. So it's taking in the 3 values. Once it gets those 3 values, they're going to be saved in value 1, 2, and 3. And then it's going to call this method, this function, sorry, show sum with those 3 values, whatever you type in. Okay, so here, when it asks for 3 numbers, it's 4, 8, and 7. Okay, so those go into value 1, value 2, value 3. So when it calls the method, the function, when it calls the function with those values, it'll actually pass in 4, 8, and 7 as the values. And then it'll actually add them, because value 1 will go into number 1, value 2 will go into number 2, and value 3 will go into number 3. It'll add them and it'll print 19. So that's what it'll look like as the output. One question that you might have, and we're going to talk about this in more detail in the slides to come, is why do we have to have these 3 parameters? Why don't we just add value 1, value 2, and value 3 in here, because we already had those values, right? So whenever you declare variables here, like in the main function, they're only good for the main function. So like this other function doesn't know about value 1, value 2, value 3. So in order for it to get those values that you have in value 1, value 2, value 3, they have to be passed in through arguments. And so in order to get them there, you have to send them there. So what it does is it says, oh, value 1, I'll take that value and I'll copy it to number 1. Oh, value 2, I'll take that value that's in there and copy it to number 2. So it's actually just sending the copy to those variables you have there. And if you tried to just take off these parameters and just put value 1 plus value 2 plus value 3, it would say it has no idea what those variables are because they're in another function. So that's one bad thing about doing separate functions. When you declare variables in one function, the other functions don't know about it. And that's good in a way because all of your code isn't always going to be in one particular file. It might be in another file. And so, you know, the variables in one file aren't going to know about the variables. So you have to learn to pass variables from one function to another. And so this is good practice to be able to send the values from one function to another. Okay, so it knows about them. It was nice when we were all in the main method and it knew about all the variables you had. But we did talk about this problem before. We talked about if you declare variables in a loop, they're local to the loop, right? If you declare variables in a conditional, they're local to that condition. So think about this. When you declare variables inside of a set of curly braces, inside of a block of code, they're local to that block of code. So in this case, the block of code for these values is from here to here. Now you might say, okay, but we're calling that function inside of that block of code, but that doesn't count as part of that. So it has to be used inside of this block of code. And because this block of code is not inside of that block of code, then that doesn't count. That they can't be used over there. Okay, does that make sense to everybody? Okay. All right. So we talked about this. Value 1 gets copied. The value gets copied into number 1. Again, these could just be values. Like the values were 4, 8, and 7. This could have just been 4, 8, and 7. But the nice thing about using variables is you can ask the user, like in this program, you ask the user for 3 integers. So every time you run it, it could be 3 different. If you just type in 4, 8, and 7, it's always 4, 8, and 7, unless you manually go into the program and change it. So a lot of times you don't have just, you know, values written here like 4, 8, and 7, because it's always the same and you have to manually go change it. You want to stay as flexible as possible. So using variables allows you to be flexible, allows people to input the data instead of actually manually going into the code and inputting the data yourself. That wouldn't be realistic to tell someone to go into the C++ code and edit a particular line to change the function call to be whatever data you wanted, right? So eventually we're getting to the point where someone's just going to enter the code and they don't know how the actual code works. It just displays the result for them. And so that's what we're trying to get to. So just putting like 4, 8, and 7 in here doesn't do that. It always is the same and you have to manually go change it. So, all right. So we talked about this passing by value. Whenever you're passing an argument to a parameter, it's just copying the value and passing it to the parameter that you have. Okay, so it's just a copy. Okay, so it doesn't affect the original variable. Okay, because it's a copy. So if you were to go change in that program that you had, if you were to go change number 1 in here, that wouldn't affect value 1 because that's a copy, right? That makes sense, everybody? So pass by value means it's not affecting the original variable that you had. Okay, so if you're passing this 5 into here, it's not going to affect this one. Okay, now I have a program that I want to show you. It's program 610 in the book, but it has a menu as one of the functions, but I have it here in the online GDB. I'm going to pull it up here. Okay, so here you can see that you have function prototypes at the top, and one of them is a show menu. It doesn't have any parameters. It's just going to basically pop up a menu. And then show fees is going to do some calculations. So it does need a double and an int. So we'll take a look at that. Let's look at the show menu. So the show menu is going to, where is the show menu? It's down here. The show menu is just going to display this list of choices that you have. So what kind of membership did you want, basically? And so we just have that as a separate function. So it makes it look nice when you're doing this. Inside here, inside the main, whenever you want to display that, you just say show menu, right? You don't have to put that long list of the menu there, and it kind of keeps it separate. So it's kind of nice to put, you know, choices like that, menu choices as a separate function. So that's just really easy to do because it's just a void function. Doesn't have any parameters or anything like that. Now, what's going to happen is here, it's going to bring up that menu, and then you're going to take in a choice. Choice is a variable that was declared up here as an integer. So here, basically, they're picking one of these integers, 1, 2, 3, or 4, as to what type of membership they want. Okay, and the only difference is it was separated into a separate function. Instead of putting this code here, up here, right where it has this show menu, you could have put that right there, and that would have done the same thing. It just keeps it separate. That way, if you decide to do the show menu in several places in your program and you make a change to the show menu, it actually updates everywhere you have it instead of having to go update it in multiple places. And so it's nice to kind of split because, again, whenever you make a change, it updates everywhere that you call that function. And so it's kind of nice because it's just one place to focus on it. And if you don't really need to change the menu, then you don't have to go look at that code at the bottom. This keeps it nice and simple. Okay. Now, if it's not, you know, adult choice is going to be 1. So if it's less than 1, because that's not one of the menu options because it has to be 1 through 4, right? So here it says if it's less than 1 or it's greater than quit choice is 4. So you could have just put less than 1 or greater than 4 here, and that would have done the same thing. But we have these constants up here that represent each of the choices. So whenever you're going to have something that doesn't change, we call that a constant. So up here, sometimes people programming like to make these constants to use for their conditionals and their loops instead of using the actual number that represents it. That way, if this would change, if the menu item choices would change, you could change it up here and it would change down here for your conditionals and your loops and everything. So it's kind of nice, again, to have it in one place to change it. Okay, so here it's going to ask you to enter a valid menu choice if you didn't select one. If it doesn't equal quit choice, which is choice number 4, right? And that was up here. Remember, quit choice is here, that variable. So if it doesn't, if it's not equal to 4, which is quit choice, then it's going to ask you how many months did you want to have the membership and take in those months. And then it's going to use that choice to see what the fees are. Okay, so if you selected adult choice, then it'll do the fee with the adult in that many months. If you selected the child, it'll do the child with that many months. And if you selected senior, it'll do the senior with that many months. Now, what does that show fees look like? Well, it's just going to print, it's void, it's not going to return anything. It's just going to print your total charges, which takes whatever comes in as the member rate. So member rate is going to be whatever you have here, okay? So where does that come from? Adult. That's right up here as a constant. The reason for this, again, by not putting 40 right here, you could have put 40 right here. But the reason for putting it up here is if those change, it's easier to change it up here than to change it down there and forget to select it in some place that you may have had that you may not have remembered that you put it. Because if you're saying through your program that the adult membership rate is 40, you have to go down here and fix it down here. And I think it's easier up here in one place to fix these different prices. Okay, so if you up the fee to 42, you fix it here and it fixes it throughout your program, right? So it makes it a little easier. So that adult is 40. So what it's going to do is it's going to take the 40, the value that you have from up here, and it's going to send that down here to this variable here. So 40 is going to get sent to member rate, and then it's going to get multiplied times months. Well, how do we know how many months? Well, that's what you enter here when you say how many months, and that goes right here. So the first argument is the fee that comes from up here, okay? And that's based on your selection of which membership type you pick. And then how many months you do is based on this number you enter here. Okay, so once it passes in those two values, then it's going to multiply and send it back. So if I were to run this, let's say we'll pick one. We know adult is 40, so I'll just pick adult. Let me have it done here. Sorry. Okay, so I will enter standard adult membership. That's number 1. How many months? Well, it's going to be $40 times whatever if I pick 5. Okay, it's going to say the total charges are $200 because it's $40 times 5, right? That makes sense, everybody? What if I want a child's membership for 5 months? Okay, that's cheaper, right? So the child's membership is going to be $20, so it's half the price of the adult, right? And then if I want to quit, I just enter number 4. What happens if I enter a negative number? Well, it's going to tell me that's invalid. Remember, we had that code that would check to see if it was valid. Remember this right here. If it's less than 1 or greater than 4, then you get this, please enter a valid menu choice. So if I want to quit, I have to enter 4, otherwise it keeps asking me. Okay, so how does it know when to quit? Well, that's what this does right here. When it does this do while, this while is going to go as long as choice is not equal to quit. So as soon as it does equal quit, this line from 63 to this do up here on line 31 is going to stop executing. So as long as this is true, as long as it's not equal to quit, as long as you didn't say you wanted to quit, then it goes back up to this line 31 and it does it all over again. It shows you the menu and it goes through, make sure it's a valid choice. But as soon as you enter 4, that makes this false and it stops going back up to the curly brace that goes with the while, stops going to the do part of it. I can post this on Canvas too, so you can maybe take a better look at it and see if you have questions on it.
Yes, please.
Okay. And again, if you didn't get to read this chapter, this might seem really overwhelming right now. You can always watch the video again. I'll post this example so you can take a look at it. But bring me any questions you have next week. That's why we have next week as well. So you can kind of sit and think about it for a while and see what questions you might have. Because if you did read it, you might have questions right now. But if you didn't, get a chance to, then you might be completely confused and not know what questions to ask. So next week might be better for that. It's kind of a lot of information to take in, but once you go through the examples and read the book, hopefully it won't be too bad. Okay, so we've been talking about returning, but we haven't seen examples with returning. So we're going to talk about how we return. So instead of putting void on there, we're going to put a data type. So what do you want to return? Do you want to return an integer, double, Boolean, string? What are you returning? Okay. So instead of putting void, you would put one of the data types. So here, here you can see that you have a void one, but it doesn't have to be void. You can actually switch it to return something. So this one's going to divide two decimal numbers. Okay. So here is where you have the divide, and it's just going to print it off. So the difference between returning and not returning is if you do a calculation and you don't return, you have to print it or you don't know the answer. If you do the calculation, you never print it, you never know the answer, right? C++ knows because it calculated it, but it never gave it to you. So you have to print it. So in this case, if you're going to take in two values and you're going to divide them, then you have to print the answer. So it has a nice little if here because it's making sure that the second argument that you have is not a 0, because when you divide by 0, you get a problem, right? So that's mathematically impossible. So you put a little if in there to make sure that it's not 0. Now, whenever you're doing it, instead of, this return is here, because what you can do, even though it's void, is if you don't want to do this part down here, you can return back to where you called it from, okay? But you're not returning a value. You're just returning back so that you don't do this particular statement. Because if you do this statement and that's 0, then you're going to get that infinite answer because you can't divide by 0. You're going to get a problem with your output, okay? So instead of printing an answer that doesn't make sense, it's going to print, sorry, I cannot divide by 0. If you try to do 0, and then it's going to return, which means it's going to go back to where it called the function from, and it's not going to print this. Anytime you hit a return in a function, it returns back to where you called it. It doesn't come back unless you call it again. So return means go back to where it was called from, and it doesn't finish anything else with the function. So if it hits this if, it returns and it doesn't come back. Okay, but if it doesn't do this if, then it's going to print the answer. So the only way to not print the answer is to divide by 0. Okay, so that's one way you can return. It's still a void, but you're returning meaning go back, but you're not returning a value. Now, one thing you could do is you can also write this function where you actually return the value. So instead of actually printing the quotient is and doing argument 1 divided by argument 2, you could return argument 1 divided by argument 2 and actually send back the answer instead of printing the answer. A lot of times when you're doing a calculation, people choose to send back the answer to return it, because then the person that's using the function gets to pick how to print it or what they want to do with it. You might not always want to print the answer. You might want to use it in another calculation or another function. And so you just want the value from calculating it. You don't always necessarily want to print it, because every time you use that function, you might not want to print the quotient is with the actual answer. And so that's why you'll see a lot of times you're calculating, it's actually a returning method. But this one's just showing you how to use return without a value. Does that make sense to everybody? You can use the return even though it's void because that just sends it back, but you're not returning a value. But if you want to return a value, then you have to use it. So as soon as you call a function that returns a value, I shouldn't say have to, but you should use it. Because if it's giving you a value back, if you don't use it, you lose it. So if you don't print it, or you don't put in a calculation, or you don't save it in a variable, then you lose it. So if you were to call this function POW, which is power of, right? If you were to take 2 to the power of 10, right? It's going to calculate the power of that and give it back to you. But what if you didn't have x equals there? What if you just had that on a line by itself? It would call that function, give you back the answer, but it wouldn't know what to do with it because you're not saving a variable, you're not printing it, you're not putting it anywhere else. So it would just float off into space and never get used, right? So if you call a function that returns a value, but you don't put it in a variable, you don't print it, you don't do anything with it, you never get the answer from it because it just floats in space. Okay, it doesn't actually give you the value because there's nowhere to put the value. So you need to have a variable to save the value into so that when this comes back with a value, it says, oh, put it in X, so I have it for later. Because if you don't put in an X, you won't have it for later and you won't know what it is. So yes, it calculated it, but you still don't know what the answer is. Okay, so this particular function is going to do the sum of two numbers. So see how it doesn't say void here anymore? It says int, that means it's gonna return an integer. By the way, you'll never have more than one return type there. You can't put like int comma void, because that's like contradicting each other. And you can't put int comma double, because there's only one return type. Because remember, each function only has one purpose, right? One thing that it's returning. It can't return multiple things. So it only can return one thing. So it's only going to be one data type. Okay. So int, you can't have comma and have multiple things. Okay. So sum is the name of the function, and it's going to have two parameters. It's going to take in a number one and a number two. They're both integers. It's going to actually just add them together, save in a variable called result, and then return result. Okay. So where is it going to send that value? Well, it's going to send it back from wherever you called the function from. Okay. So wherever you call the sum function, that's where the value is going to go. Okay. You actually don't even need all this code. You could actually just say return and put the equation. I think I have it in here. Hold on. Yeah. So here, when you actually get the result, it's going to return it back. The return type is going to be integer. That's written here. And if you wanted to condense it, you can condense it into just the equation, just return it. It'll do the calculation and return it. You don't have to have a variable you save it into, then return the value from the variable, because it's just an extra variable you're creating. So if you want to do an equation, you could just do an equation and return the result of the equation. You don't have to have a variable to save it into, then return the value from the variable. But if it makes sense for you to break it up step by step and save it into variable, then return the value from the variable, by all means do that. It's not that much space. If it helps it make sense, that's perfect. But eventually you'll probably get to a point where you won't do that and you'll just do it simplified like this. Okay. Any questions? Okay. Well, just let me know if I'm going too fast or too slow. Whatever works. Okay. So here is that particular function. So here's the prototype. There's no variables there because this is just the prototype. Let's go look at the actual function. So you just saw this in the slide before. It's going to have it condensed where it does the equation on one line. And so what's going to do is you're going to have to pass in two values, one for number one and one for number two. Okay. So if you go to the main function, you can see here you have a value 1, which is 20, and a value 2, which is 40. So whenever you call the sum function, you're passing in value 1, which is 20, and value 2, which is 40. That comes from up here. Okay. What's going to happen is it's going to take that value 1, which is 20, value 2, which is 40, and it's going to pass it here. Value of 20, value 1, which is 20, is going into here. So 20 is going into number 1, and 40 is going into num 2. Okay, it's going to add 20 and 40 together. Okay, so you're going to get 60. It's going to return 60 back from where you called it from, which is right here. So the 60 is coming back to here. Where is it going? It's going into a total variable. What if you didn't have a total variable there? You wouldn't have the answer. What you could do, if you wanted to, is you can actually do a C out and just call the function right from the C out, and it would just print it right there. You don't have to put a variable and then print the variable later. You could do a function call right from the C out, and that would work just as well. You could do a function call inside of an equation, do a function call inside another function call, whatever works. But you don't want to just have a function call that returns on a line by itself with nothing, because when it returns the value, it doesn't have anywhere to go. So you got to watch doing that, because that does it, but it doesn't ever give you the answer. So when it saves it in total, this is where you're going to do the C out. You're going to say the sum of value 1 and value 2 is whatever the total is, which will be 60. So it says the sum of 20 and 40 is 60. Everybody with me? Okay, any questions? Y'all okay on Zoom? Did I lose anyone? Okay, I know there's a lot of slides and this is a lot to take in, so you might need to replay the video or make sure you reread some sections of the chapter. Everybody learns at a different pace, so some people can read it once and get it, some need to keep rereading it. This is getting more difficult, so I wouldn't be surprised if some people need to reread it a couple times to get it. So you've probably never done anything like this, so something new and might take a couple times to get it. All right, so this is what we were talking about before. Whenever we call the function, We pass in 20, it goes to the first one. Value 2, which is 40, goes to the second num. It adds them and it returns it back here. Now it goes in order. It doesn't really matter in this case because it's just adding it. It would matter if it was a different equation, but it does go and do the first argument to the first parameter, the second argument to the second parameter. It does go in order. So you need to make sure that you put them in order when you're actually doing the call to the function. Okay, so here's another example. This one has a function called square. It's down here. And it's going to take in the radius. It's going to, whatever, let's say you had a value for radius somewhere in your program, okay? It's going to take that value and transfer that, oh, here it is, 10, to number. Okay, so 10 goes to number, and it's going to multiply number times number. It's going to send that back, which is 100, back up here to where you called it from. And then it's going to multiply that times pi, and then save that in area. So remember before I told you that you can actually call a function inside of an equation. So this is an example of that. It's going to actually get the value from calling this function and then multiply it times pi and then save it into area. Okay, so you can do function call inside an equation and it'll actually bring back the value for the function and then use that value for your equation. Okay. Okay, so whenever you're doing the prototype, you have to indicate the data type of the return. If you're returning a value, then you wouldn't put void, you put the data type there. Whenever I talked about this too, there's 3 ways that you can really use the variable that you're returning. You can either print it, you can put it in a variable, or you can put it in an expression like a equation, like you just saw in the previous one where I multiplied it times pi. But if you just put it on a line by itself and you don't do anything with it, you just call the function, but you never put it in a variable, you never print it out, you never use it in an expression, it's going to do it, but it's not going to give it to you. You're still not going to know what it is. So be careful of that. Okay, sometimes different editors will warn you of that. It won't be a compiler error, but it'll say like you never use this value, something like that, because you're doing it, but you're not using it. Sometimes depending on what editor you're using. Okay, a Boolean function will return true or false. So it would be bool as the data type. So you can have a function that returns a bool, which is true or false. Okay, so here's an example. So this prototype is set up, and see how it says bool here? That means it returns true or false, but it takes in an integer. And the reason is because it's going to check to see if that integer is even or not. Okay, so if we look at the function, it takes in a number, which is an integer, and it's going to check to see if that integer is even. So this if statement is going to see if when you divide that number that you passed in by 2, is the remainder equal to 0? If it is, then we're going to say that it's true. If it's not, which would be else, it's going to say it's false. So we have a Boolean status variable up here, which either gets set to true or false. And when you return status, it's either going to be true because it did the if or false because it did the else. And that's what's going to get returned. Okay. So when it gets to the return, it'll either send back true or false. And so here in the main method, you ask the user to enter an integer and it'll tell you if it's even or odd. It's saved into a variable called val, V-A-L, and then it's going to pass val, whatever number you entered, into this method called isEven. Okay, and so when it determines whether it's true or false based on this condition here, it's going to either be true or false. Now you can actually put this right inside of an if, and if this comes back to be true, it'll do the if, it'll do the cout for the if. If this comes back to be false, it'll go to the else, and it'll do this one. You could have saved this in another Boolean variable and then use that Boolean variable for the if, but this is kind of nice because it's a simplified version of that, of doing that. You don't have to say isEven and then the function call with the value and everything. You don't have to say equal true because it's assumed that if you say if and it comes out with true, that will match. You don't have to say equals true. Okay. Everybody with me? Y'all okay? Okay. All right. We talked about this a little bit. So local means that it's inside of a block of code and you can't use it in another block of code. So you have to be careful of that. If you have variables in one block, they're not accessible in another block. Okay, so we have this program, we have this another function that is declared. Here's another function down here at the bottom. Another function has a variable called num, which is 20. Okay, but this main has one called num, which is 1. So which one is it going to use? Well, it's going to say here in main num is 1, right? Because in the main method num is 1, because that's the local one. When you call another function, it's going to go here and say, and another function num is, well, what's the num in this one? 20, right? Because we're in this function now. So it's going to say it's 20 in here. What happens when we come back here and say back in main num is, are we going to be 1 or 20? 1, good, because we're back in the block of code where that variable is. We're not in this one anymore. So it's not gonna save over top of the other one. So think about this, even though they have the same name, they're in 2 different reference locations, even though they have the same name, because they're in 2 different blocks of code. So even though it's num and it's num, it's really like having 2 separate variables because they're in 2 different blocks of code. So you have to keep track of them. Okay, so it's 1 because it's that in that block of code. Okay, everybody see that? Okay with that? All right, so when you're in that block of code, that variable exists, but once you got out of that block of code, you don't have it anymore, you don't have access to that. So you have to be careful of where you're declaring your variables. Be careful if you declare a variable inside a loop, it's only good inside the loop, and a condition, it's only good inside of a function, only good in that function. Okay, if you make something global, if you were to define something at the top of your program, it'd be good for the whole program. But you have to be careful doing that because there's reasons for wanting to pass variables from one to another, and you really do need to know how to do that. Okay. And whenever you are going to have global variables at the top that you're going to use throughout several different functions, we usually make them constants because they're going to be used throughout several different functions in your program. So you can declare the variables at the top of your program outside of your main and all your other functions and make them a constant, which can be used in any of your functions. Okay. But don't just do it just to avoid passing variables, because you really do need to know how to pass variables. So don't just put variables up there so you don't have to pass them, so all of the functions know about them, because then you don't learn how to do parameters and arguments. If you do that, you skip that part, but you need to know how to do that because eventually you'll be doing that and you won't be able to get away with just putting everything at the top of your program as a global variable. So this is an example of a global variable. It's at the top, it's not inside of the main function. So that means that any of your functions in this program will know about these variables. And so you have a pay rate, a base hours, and a OT overtime multiplier. Okay, so this is main, and see how this is at the top. So any of the functions can use these, and then here's the prototypes, meaning you're going to have a get bay pays and a get overtime pay function. Okay, and they're both going to take in decimals. So if you go over here, this is still the main. Okay. Oh, wait a minute. Where's my? I'm skipping some code, I think, in there. It goes from line 20, and then I have 29. But it does show how the constants are used. So if you have overtime, you can use base hours, and then you can use them here. But it doesn't have the methods, like the functions. I get it right. The functions that go with it. So I think I'm kind of skipping code here. So that's not complete. I'll have to get that complete program. Sorry about that. That would be easier to see the whole thing. Okay. If you have a local variable, it's not automatically initialized. Initialized means given a value. So you'll have a compiler error if you try to run something that's not initialized and you try to use it without giving it a value somehow. If you have to give it a value at one point. If you give global variables at the top, they'll automatically be initialized to 0 and null if you have like a string or a character. But you want to try to initialize them anyways instead of letting them be default initialized for you. And so initialize just means given a value. That makes it easier. Okay. And then you can make things static if you want them to keep their value between function calls. So, we talked about values, whether you're going to here, I'll just show you a program actually. I think that's probably the easiest way. So here's main, and main has just a function call, and it has another function call to the same function. Okay, so show local. So here local, you can see here has a local num variable of 5, right? And then here you can see out, and then it's changed to 99. Okay, but then here when you call it again, it's reset back to 5, and then it prints. Okay, so here, where's my static? Okay, so where's my, okay, so that one changes, but if you have a static variable, so this one says show static, so let's go to, it'd be easier if I had the program all on one page. Sorry, it's for a separate slide. So if I go to the show static method, then I have a static variable. See how we have the word static there? And this one is called statnum instead of just being a regular variable. And so see how if this one prints and it adds 1 to statnum, whenever it comes back in here, it's not going to reset statnum. It's actually going to continue with it. So if you had a loop, that would go from 0 to 4 because it stops before it gets to 5. So it goes 0, 1, 2, 3, 4. Each time counting by 1. So it goes 0. And the first time it calls show static, it's going to say statnum is, and it's going to print 0. Okay, but then it's going to add 1 to it. Now, if you didn't make it static, when you called it again, it would go back to 0 again. It would just print statnum as 0. But because it's static, when you added 1, it would actually print the new one. It would, instead of resetting at 0, and then it would increment each time, because this incrementing wouldn't have happened if you kept recalling it, because if it wasn't static, it wouldn't keep track of what it was last time. It would just reset it each time. So that's, I guess that's the best way to describe it is, if you're going to have a variable that you want to increment for some reason or want to change, and you want it to, next time you call the function, you want it to remember what it was before, instead of resetting it, you make that variable static. So it's not that common. I don't think that you'll want to do this in your programs, but it's good to know, because you don't, if you want to keep incrementing, you don't want it to keep resetting it. Static is the way to do that. So in between function calls, you want it to stay the same, make it static, and it'll keep that same incrementing that it had before. Does that make sense to everybody? So the first program I showed you kept resetting back to 5. This one, because it's static, it actually keeps the new value. Okay. Oops. All right. If you want to, whenever you're doing your prototype, you can actually set up a default value for your function. So if you want your variable that you're passing in for even and odd to be defaulted 0, if they don't have a value for it, then you can set that at 0 by just saying, you don't put the variable name, that goes in your header, but in the prototype, you actually put equals 0. If you have multiple parameters, you always put the ones that don't have defaults at the beginning and the ones that do at the end. Okay, so for example, the first one doesn't have a default, but the last 2 have 0 as the default. So you can set up a default. So like this one, for example, has a default of 10 and 1. Okay, so what does that mean? That means that if you call the function and you don't pass in a value, it'll just default with 10 and 1. Okay, if you didn't have these defaults, then you couldn't do this, because there would be no default. You couldn't do a function call without having an argument that's needed for the actual function. So in this case, see how this function says you have to have columns and rows to print out? You have to have a number for columns and 1 for rows. If you didn't put that default in there here of 10 and 1, you couldn't do this function call without having an argument for each of those. But because I have a default here of 10 and 1, then I can do a call without having argument, because it'll go with 10 and 1. Okay, but if you don't want it to have those numbers, like for example, maybe you want to change and you want to pass in 5, then it'll use that 5 instead of 10. Okay, and then if you want to do both numbers, let's say you don't want 10 or 1, then you just pass in 2 numbers like 7 and 3, and it'll do 7 and 3. So it'll put 7 in columns and 3 in rows, and it'll do that with 7 and 3. But if you don't pass in anything, it'll do it with 10 and 1. And if you pass in 1, it'll replace the first one and not the second one. Okay. Everybody good? So you can have defaults. It's kind of nice to do that. If you don't want to force people to have values, you want to give them a default. In case they try to use your function without passing in values, you can default to something if it makes sense to do that. If you want them to require them to have values, then don't put defaults, because that will allow them to get away with doing it, which is the default, without having values. Okay. Again, you have to put the ones that have defaults at the end. You can't put it like in the middle or at the beginning. So in this case, you want this one's in the middle. That's why it says that one's not okay. The other two are at the end. If you want to omit an argument, like for when you're calling with the default, then you can't do it with just putting a comma and skipping like this. You have to do it like this. So you basically have to do the ones that are required at the beginning, because that's the way it's written. The ones at the beginning are required and the ones at the end. And if you have defaults for all three, then you don't have to put any values in there. And if you choose to overwrite the ones that they have, then you would just put the numbers that you want in there with the comma. But that's why this one's not okay, because this way this is written is not okay. So you can't use this one like this. You can't skip like that. So you have to do it like this, and then it would do number 1 and number 2 instead of writing it this way. So this doesn't work. Either of those don't work. Okay. Sometimes we can use reference variables as parameters. And so sometimes you want the variable that you're passing in to change whenever you change it in a function, and you put a little ampersand there if you want it to change. So if you're doing a function and you're writing the prototype for that function, you put the little ampersand here. That means it's by reference, okay? Because by default, remember, you're passing by value. If you want to pass by reference, you put the ampersand. So that means whenever you pass the variable, if it changes in your function, it's going to change the original variable, okay? So here's an example. Here's the prototype with the ampersand. This part looks the same, but let's go to the function. Okay, so here the function has the little ampersand, meaning you're passing by reference. So this variable here, this ref variable, ref var variable, is going, when it's multiplied by 2 and replaced, it's actually going to change the original variable. Okay, so back here when you call it, this value of 4 here would get passed. This 4 would get passed, but whenever this actually, when the 4 actually references that original one here, this value, so whenever it multiplies and replaces this reference value, it also changes that original value. So instead of being 4, it'll be the new one. So see how here value is 4, so it's printing okay. And main value is 4, calling double num. Double num is going to pass in 4, but it's passing by reference. So whenever it multiplies by 2, so it takes 4 times 2 and you get 8 and replaces it, it is going to change reference variable, but it's also going to change the value because it's passing by reference. So whenever you go to print value again, it's going to be 8 instead of 4. So it actually referenced this. So if you don't do that little ampersand, it won't change value. It would be 4. But if you do, then that's one way to change it. And see how I didn't save? I didn't save in a variable back here. And I don't need to because I replaced the original value variable by doing by reference. So that's another way to handle it, because think, you're not creating another variable to save it into because you actually referenced and changed the original variable. So value is now whatever it was in this function, whatever the result of this is, value is that. So you don't have to create another variable because value is the answer to that function because it was referenced. So that's a different way to think of it. Does that make sense? Okay, perfect. All right, guys, getting there, right? Whenever you're doing it in the prototype and you're doing it in the function header, you have to put the ampersand because that's what tells it to pass by reference. Otherwise, it passed by value by default. So it won't affect your original variable. If you do the ampersand, it affects the original. And then you can pass back and save in a variable, but you don't need to because the original variable is affected. So you can use that in your code instead. Okay. Overloaded means that, okay, so when you're writing a function, sometimes you might say that you want to have 3 parameters, but maybe, and you can do this with doing a default, but you can also do it with overloading. Overloading means you can write the function several different ways with different number of parameters. So you can actually, if you wanted to have, you know, a method that was going to, a sum method that was going to take in 2 integers and a sum method that was going to take in 3 integers, you can write them, and if you both name them both sum, that's called overloading. But how does C++ know which one to do, which one to use when you call it? If you put in 3 arguments, it matches the one with 3 parameters. If you put in 2, it matches the one with 2. So based on the parameter list that you create for your method, the argument has to match. And if you actually name the functions the same thing, like you have this function here with this many parameters and this one with the same name with this many parameters, and the parameter lists are different, of course you can't have the same because then it wouldn't know which one to use. Then it knows which one to use based on how many arguments you put in. And so it's good because you can give the user different options, like if they wanted to use it with 2 arguments versus 3 or 4, or maybe they didn't want to supply any arguments. And again, you wanted to go with default values. You can do that with overloading as well. So here's an example. So you can have, these are the ones with 1. These are the prototypes. So this one has 1 integer, this one has 2. This one has an int and a double, and this one has 2 doubles. So you can also do that. You can write choices of whether you want to use like doubles or strings, or what do you want to use as your parameters, and it'll match the one that has the argument has the right parameter. So that's another option. So here, like if you just take in the length, maybe it'll default the width for you. And then this one has length and width, this one length and height, maybe length and height and base. So you can have different options, but they're all called get dimensions. How does it know which one to use? Based on the parameter types. Okay. Okay, so here's an example. They both have square. One returns an int, one returns a double, one takes in an int, one takes in a double, right? So here you can see you have one square method that takes in an int, returns an int. It just multiplies number times number. This one's the same thing, except it uses double, right? So which one do you want? Well, when you use it here in main function, you get to decide which one you want to use. So when you actually call the function, if whatever you pass in here is a double, it'll use the one with double. If whatever you pass in is an int, it'll use the one with int. So this one passes in an int, and then this one passes in a double. So whenever you're using it, they get to pick, do they want the int or double version of it? Okay. Well, that's pretty cool, right? Everybody's super excited. Okay. Again, I know it's a lot to take in. So in 92 slides. Almost kind of had it. We're going to tone down a bit on next Wednesday because I just want to show you some examples and answer questions. I want to ask you some questions. This is kind of a lot, so I hope that you take this week to just kind of review the chapter, try the exercise, and do the first discussion board entry, which we'll talk about in just a bit. But it's a lot of information to take in. So again, I don't think that anyone's just listening to this once and getting it. And if you are, that is fantastic. If you've already read it, hopefully it makes sense. But if you haven't read it, you're going to need to read it to make it make sense. That's why I give you points for reading, right? So you can terminate the program with the exit function. And you need a special header at the top. Don't use this too often, but so you can exit. You can do different conditionals to see whether you're having problems and test that. I don't know if I have any examples, but I'll see if I have examples of programs with this because that would help, I think. So I'll look for examples of that for next week to kind of help you with that. You want to, whenever you're doing it, you want to test everything you do. You're always testing your code. They actually have people that have jobs, they're called testers. And it's their job to just test code and try and break it because you want to break it before the customer gets it because that would be really bad. So you're always trying to test your code. Hopefully you're testing your code multiple different ways. I know that we haven't done anything that complex, but maybe you test it with one value and it works, but if you were to test it with another, maybe it doesn't. Maybe you just got lucky. So you always test it with at least 2 values or more to make sure it works. So you're going to test your functions as well and make sure that you're passing different values to make sure that you're getting the right results. Same thing. So we can have a function that tests another function. We call that a driver. And I hope there's an example of this. I'm going to have some examples of this next Wednesday. So I think that's kind of enough for today and those last couple of slides. I don't have example code up, so it's hard to kind of show you, but I'm going to try to get more examples for you next Wednesday, and we'll take a look at all of those. And you can kind of take some time to process all this, I think. And hopefully the idea of using a function makes sense. One of the problems with when we're first starting off with functions is the programs aren't too difficult and it doesn't make sense. A lot of students will say, why would I put the calculation in the function and then call that function so I can return the result when I could just put the calculation in the main function? Like, why would I do that? Eventually things are going to get more complex and you're not going to want everything in the main function. So if you could step back for a little bit and say, this is just practicing with the syntax and learning how to get from there to here, because eventually I'm going to need to know how to do this because it's going to get impossible to do this all in the main function. Instead of showing you a line code that's like 600 lines of code and showing you, hey, this is why you'd want to do this. I think what always happens is the book tries to make it as simple as possible with really simple examples. But sometimes what gets lost is the meaning behind why we would ever do this. Like, why would you have a function that just does a calculation and sends back the answer? One of the main reasons is reusability. Okay, so if you were doing code that makes sense that you would, reuse in the future, then you would save that and you would keep bringing that into future projects that you have. Okay, but the equations that we're using, we probably wouldn't save and bring into future because they're just simple equations. So again, I know you're saying to yourself, I'm going to multiply a number times a number. I could do that easily in the main function and I wouldn't need a separate function to do that. I understand that completely. And I'm exactly where you are. I was there at one point and I didn't get it. So I hear you. I promise that if you continue with programming, eventually it's going to click and you're going to say, I understand why I need this. But right now it's a little hard to understand why until you see bigger programs. But at this point, it's hard to give you bigger programs because it wouldn't make much sense. So it's when you keep the program small, one of the drawbacks is you can't understand why this would ever be meaningful. And then when you get to larger programs, you'll start to understand why it's needed and why you can't put everything in a main function and why that is not manageable and why that's not flexible and why that creates issues. But it's hard now to see that. I remember when I started my first programming class, it was C++ in high school. And I remember doing it and I loved it. And then we got to functions and I said, but why? Like the book didn't say why. I just didn't understand why. Like, why did I have to take this simple equation, put it in another function, decide if it's returning or not returning, worry about all these different words, how many parameters do I need and what arguments do I need? Why do I have to put all that extra code? Why do I have to call it? Why do I have to put a prototype at the top? That seems like a lot of work. Why can't I just put that equation in the main function? And I did it because the book said I had to do it and the teacher said I had to do it, but I never understood why I did it. And it wasn't until I took future programming classes and the programs got larger that it actually clicked and I said, that's why I learned this. There was a reason for that, but I understood and now I understand it, why they make it easy. But if you could just think that maybe you have something that's a little more complex and you don't want to keep rewriting that code, you want to share it with other people and you want to reuse it in the future, breaking it down into modules makes it easier to do that. If everything's stuck in your main, you're copy and pasting and it just doesn't work. It's easy to share modules, but it's not easy to share things that are stuck in a main function. And that's the main reasoning. And I know that you might not see that sometimes, and you might not understand the reasoning for that. And so hopefully as we get more complicated programs, they'll start to make more sense. But it's hard in your first class to get complicated programs. But once you go into your second class, you need to have that being able to break things into separate. Because if you go to the next class, you're going to be doing Java and you're going to get more complicated programs. You're not going to be able to keep everything in main. You're going to have to split it at some point, and that's all going to start to connect and make more sense. So I hope, anyways, that's my goal. So we have to do it for now. And although it might not make complete sense because they're simple equations, and I get you, putting it in the main function would be easier, and it doesn't make a whole lot of sense to take a simple equation like summing two numbers together and putting it in a separate function. The goal at this point is to make sure you can do it when you get to that point of more complicated programs. You have the ability to do it because you've been practicing it. Whereas now you're seeing, I'd rather just sum those in the main function. Like, I don't get that. I get that. I totally understand. And I'm with you. But just hang tight because eventually it will make more sense. Okay, so what I want to do is see if there's any questions. First of all, I know that these last couple of things, I'm going to try and get programs for those to make those make more sense. I had programs here, and then I stopped having programs for the last part. So I will do that next Wednesday. And then I want to talk about the discussion board, but does anybody have questions? Okay.